to my video. So from this video, we will move to the programming challenges for chapter 6, drawing geometric shapes and fractal. There's 4 challenges. We will do this one by one. First one is like these pictures showing. It's called packing circle into a square. So it's giving you a square, you know the length of edge, and then we put our the circle with the unit radius, and then we see how many circles you can put into this square, and draw the maximum like this way. So before we can make this the drawing, we learned from this chapter when we do this the geometric shapes. We know we can use the this SymPy. We can have a draw shape through this patch the module, and we practice draw the circle. But we haven't yet learned how to draw our square. So let's do this first. So we have our sample code from author here. Is when you want to draw a square, is have the 4 edge. Actually, is we are using the polygon, the patch to draw that. When the polygon you define 4 the corner, that is the 4 edge. Then when you close that shape, it will be our the 4 edge shape, and if you put this 4 edge are the same length, that will be a square. So let's try this one first, and we will use this as our submodule in this real challenge. So first, let's go to our chapter 6, make the new 06031 draw square .py. So let's make our purpose, draw our square. And we need this matplotlib, so not the SymPy. So matplotlib, we can use this from way, or we can use our the standard way. So through this matplotlib.pyplot, import this as plt. So that is our parse. Then is if. Just call our simple new function called draw square. Then we will do this draw square definition. And from here, we will have the PLT show. So draw square. So if here draw square, we have nothing putting here. So EX. Oh, not like this way. So we should have the def. Then these are our minimum working the program. And we do this polygon. So polygon is we have this EX, put it as the XL, and we put this range is X limit is from 6, 0 to 6, and the Y limit is also 0, 6. Then we have this square, and we have ax.add hatch. So let's run this. So we haven't do anything here. So the square, let's define this one. So square has 2 argument. One is your polygon, the list of those coordinates, and then this final is the closed, is true or false. So we have PLT polygon. So that's the keywords. Then it's a list. So using this square brackets. So let's make that bigger. So we can starting from 1, 1. All let's see is if I want to start from 0, 0, though it will putting is from your origin. But since we have from 0 to 6, we make that from 1 to 5, then you can see all the corners. So every the coordinates pair is tuple. So 5, 1, 1, 5, and oh, it's a 5, 5, and 5, 1, 5. So if we put this directly here, so let's have a look. So polygon has the didn't so it's the capital P. Let's not put this closed to see what happened. So it's also our this polygon. So by default, I think is you can drag this and make that looks really like our square. So closed equal true. So you can see that is the same. If I put is false, let's see what happened. Nothing. So maybe I put remove 1, so like a triangle, I hope. So you can see here, they have the this in field. Looks like is that they have the field color, so themselves. So those are the things. So we have when we put 4 parts, then we make a true. So then that's gave our this polygon. So if you keep drawing, so maybe it's, if you see here, I'm not going to this one. I go to the 10, and then I go to this 10, 5, and go to here. Then you get our 5, 5. You can see here, you keep getting those and close is true. So let's see. First, I go to the left, bottom left, right, bottom right, and then go to the this and go to here. So maybe it's I go to here, 10, 8, 10, 8, 8, then back. Then that's a closed shape. So it's like this way. So, but it's beyond your limit. So you don't see that actually. So if I put this, it's 16, 16, then you can see the complete one. Now is our this 1, 2, 3, 4, 5, 5 points. So let's back to our square. So that is the square. So let me save and run. So this is what I will put that as our base. And then this now we have a square. For our challenges, we will attempt to put a very simple ways, just our circle from the bottom left hand corner to using this nested loop. Then we can put that inside. The trick here is to start from the lower left corner. Then this starting, our start point is 1, 1. So your unit radius length, the circle, the first, the center of circle coordinate will be 1.5, 1.5. So that is the tricky part. And then after this, you can start to add one to go to the next parts. So those one is let's copy this to another one. So because we will use our square in the right, in the outside. So then that is the one is the packing circles in a square. So that is our 1, 1. This is 2, and this is 1. Then let's go to here. So let's make our purpose. So it's packing circles into our square. So we just carry on using this square. So and then this we don't need another the library, just this library, and we have our draw squares. So first we will draw squares there definitely. And then this we will put these draw squares to our the variable. So then that's we can use that later on. So S is we call that is the square. And then this within here is we should define our AX started. So then in the draw squares, we don't need to do this definition. So this PLT GC so is the same as this one. So then this we will put this delete. Then we draw our square, close is true. Then this we will we don't add here, so we will return. So just return a square. And then here is we make S is equal to draw square. Then when we return, we will get a square. Then whenever is we keep add this S, then that means we add this into the patch. So AX dot add patch S. Then we have is our PLT dot show. So that is should be the same way. We got our square, but we haven't draw the squares. So we should have the let's say PLT is scaled. Let's see our square. PLT square is this polygon, this 1, 1, 2, and return square. Then here is draw square is this one, and then we make is AX add patch is S. Let me see. Oh, here is have our parentheses. Yeah, we have this one. So now our square is has the automatically scaled. It's not starting from 0, 0 until 6. It looks like it's just quite close to this corner. And we can make that smaller. Then that is our square first. Then we have this, and after that is we will draw the circle. So then let's see. So well, first we should put X and Y. So if we have this first is the X is 1.5, Y is 1.5. And whenever is this y is not go more than 5, then is we will keep x is 1.5. If this y is more than 5, then we will add x and then return y. So that is the thing is if they are not over this, then we just draw the the horizontal circles until x is more than 5. So that is the logic. And first is let's also make our this draw circle. So the circle is we can send up our P, I think is then we have defined the P. So if we want to make it that is while, so let's do while is not go more than 5, then x will be 1.5. So that is the first while. And then we will see while x more than 5. So we should have a starting point is y is the started from y 1.5. Then this we will draw the first one. So draw. So P is x, y. Then we put this circle P. So we send our the P to this here, the circle. Then what is our circle? Let's see. So we use this coordinate is PLT dot circle. So both is this polygon circle are the square in the beginning. So then we have a P and the radius equal to 0.5 and face color is yellow. So we will put that and then we return a circle back. So now is we have a C is our circle, and then this we will add C. AX add patch C. And then here, once we finish this, is x plus equal is 1.0. And in the first round, this level, we will add y, because now is x will be more than the 5. So let's see whether we just transfer the p is working. Yeah, same. So you can also, not like me, is you can just here, you can transfer x and y, but here you need to also use x and y. Here is a tuple x, y. So, but for simpler is if we package our coordinate into our x, y pair, then your function call will be a little more simpler. So here you can see is we have this way. So and then is let's extend this a little bit is to have the bigger one. So we put that as our the variable. So we ask user to give us this upper the upper right corner. So the big. Or we can see the size of the this the square. So let's see. So is the size the edge length is equal to int and input, enter the length, edge length of square. So if we have this, we will starting to use this one. So then we this 5 will be the 1 plus because we are using the 1. So here we will do this length is this plus 1. So that is our this looping. And also we will use here. So this will be 5. So until y is here. So this one should be the we starting from this one, and this should be length plus 1 as well. So here as just since it's getting longer, so remember I suggested is if it's too long, is try to put your these arguments in multiple lines, so that will be easier for you to do the troubleshooting. Let's see what any other parts have the hard coding. No, so now let me see. It's asking me let's double this. I have the length. This is the 10. So now I get 10 and still use this the unit length reader circle to packing inside. So if I have the more than bigger, so if I put 100, then you will see a lot of these circles inside. So it will draw I think it's 100 times 100 is almost the 10,000 the circles. So it's kind of slower, but yeah, that is our purpose. So if I make the zoom, so you can see here, it's actually fading by those circles. So that is then is just a little enhancement to make certain hard coding by replaced by variable. So then you have a little more flexibility for running this code. So also, I believe is you can use this edge, the reader. So let's see the readers is equal to another one. So let's see the reader is just the float, the input, the reader. Yeah, until now, our circle is still to keep the same readers. Enter the reader of circle to pack inside. Then we got our reader with a float. Then let's see. So if we have x is the y is 1 plus these readers. So let me see. So if I have here is yeah, just 1 plus reader. Y is starting from here. X is also starting from here. And our reader, so we send the reader also. So and here is readers. Just I think it's R. So we put that is R. So here is getting the dynamic, and let's see here. So once we have that, is we will add. These are the double reader. So 2 times readers, and also we will put this change. So now our code is getting more flexible. So it will ask you have both the packing. So if I have a bigger one, maybe it's too slow. So let's just have 30. And the reader is I can make that bigger. So as 2.5 now I can give a float. So it's just C here. So 2.5 and 20. But what if I gave something is let me see here. If I put 40 and then this I gave something is this reader is not able to pack in the integer one. So let's see. So 7.5. Oh, that's 7.7. So that definitely, yeah, is beyond that. So, but so you can see here, we may have another the mechanism to control is should not be overflow. So maybe that will be better. We only have 4, not this 9, because once it's a reader is still the inside is 40. So, but now you can see it's just is go to the one edge, and you can keep having this part is like this. I have 6, so either is you can either is not match the reach the edge, or you are a little overflow the edge. But this mechanism is the packing. You are certain shapes repeatedly in your an outside shape. So I hope this discussions give you some more idea for draw the more kinds of the shapes. Now we learned the circle, we learned the polygon. So using polygon, actually you see is we can draw the 3 edge, that's triangle, 4 edge, that can be the square, or can be the rectangle, or you can draw whatever the numbers of edge, then that is a real polygon. And then this you can we also have the nested loop to try to put our circle inside on the inside of your exterior the shape. So with the different color. So also remember we use our this feature, or these arguments is FC is a face color. Then this we have the this implement the function. So hope you also get the same result. You can use the my original way, so with all the hard coding, or you can try this more dynamic way. Both the edge length and the radius can be input by user. So then let's stop here. Next video we will draw this nice the fractal triangle. It's called this Sierpinski triangle. So that will be used over this fractals the knowledge to do that. See you in the next video. Bye for now.